In the past century, we have successfully extended our presence in space. We are no longer earthbound as we had once been. Maybe our real home lies on the high frontier, on the second largest moon in our solar system, Titan. We hope to contribute to the actualization of human potential on Titan and energize global efforts towards space development. Now, introducing ways of extending our influence to Titan. Titan is the largest moon of Saturn and is the only moon known to have a dense atmosphere. It is also the only body in space, other than Earth, where clear evidence of stable bodies of surface liquid has been found. Titan's atmosphere is largely made of nitrogen, followed by methane and hydrogen. It helps block galactic cosmic rays, which penetrate human tissue, causing cancer and disorders. The thick haze creates an atmosphere that retains heat so it will not get colder than it already is. The climate, including wind and rain, creates surface features similar to those of Earth, such as dunes, rivers, lakes, and seas of methane. Titan also has land similar to Earth's, but made of ice. Cryovolcanoes are found to spew ice and hydrocarbons instead of regular lava we see on Earth, which led to the conclusion that 100 kilometers beneath Titan's thick crust of ice is an ocean possibly made of water and ammonia. Underneath this liquid water ocean, there are tetragonal crystals and the hydrous silicate core of Titan. Titan has many available resources that humans can utilize to sustain life. Titan is rich in hydrocarbons. We hypothesize that it is possible to utilize the available hydrocarbons in the upper atmosphere to power the technology required for life on Titan, such as underground transportation, laboratories, and satellites. Hydrocarbons can retain heat and undergo polymerization to form man-made materials such as nylon to provide warmth. Scientists have also hypothesized that there is an ocean of water beneath the icy crust, which can be used to sustain life after the treatment of ammonia. Renewable energy resources on Titan include chemical, nuclear, wind, and hydropower. Electrical power could be produced using chemical power plants adding hydrogen to acetylene. Turbines enlarge methane seas, such as Kraken Mare, where the tidal pool of Saturn causes up to a meter of tidal change each Titan day.
First and foremost, one critical thing Titan lacks is oxygen. Animals, plants, and humans require oxygen to survive. According to publications by John Cooper, the forces that generate the Enceladus gases spill water vapor into space. Oxygen and broken water molecules circulating the upper atmosphere can be carried all the way to the surface without further chemical contamination, like being encased in carbon cages called fullerene. Coupling these methods to existing theories of transporting oxygen across the magnetosphere, we propose to establish a continuous chemical pathway that allows oxygen to be introduced to Titan's surface chemistry. Alternatively, we can use a nuclear reactor for nitrogen-14 to be converted into oxygen-16. We can also rely on wind energy as an energy supply for the electrolysis of water to produce oxygen and hydrogen. Secondly, because of transportation costs, we will have to depend on new closed biological systems to provide human sustenance. Laboratories should be set up for various experimentations, and one being the production of food in order to sustain life. Hydroponic farming and genetically engineered plants may prove a boon. Furthermore, with the fine-tuning of plant-based food technology, we would be able to mass-produce plant-based meat on Titan. Lastly, while the temperature on Titan's surface is significantly lower than that of Earth, we could live underground where temperatures are higher. This would also mean easier access to water. Since the pressure in the Earth's inner core is slightly higher than it is between the surface and inner cores, it's likely that the pressure in Titan's core will not be much higher than that on the surface.
What should we expect from life on Titan? Titan's atmospheric pressure is slightly higher than Earth's atmospheric pressure, which allows humans to roam its surface without a spacesuit. A year on Titan is equivalent to 29 years on Earth. A normal human would only celebrate 3 birthdays on Titan in their lifetime. Fashion will have to be designed to serve purposes like protection and comfort. In 1984, for example, cosmonaut Svelena Savitskaya commented that her spacesuit was not elastic enough and that she had to expend too much energy for each movement. We will have to invest in space fashion for our Titan settlers. With much weaker gravity, there is room to innovate and modify existing transport systems. For example, instead of rail systems, Titan could use maglev. Modern communication technology and satellites will have a primary position in information sharing. For education and training, the first Titan colonists will rely on a variety of modern media alternatives. The work culture will be meta-industrial and feature the use of high technology. Work can be done by robots operating automatically or under the manual guidance of humans. On the surface, work may involve mining and processing of new materials. Competence in one's field of expertise and multi-skillfulness are expectations that will emerge. We hope that in the future, Titan will become a second home for humanity and one day, humanity would finally step on this frozen moon.